Hey everyone, welcome back to the channel. Today, we're diving into one of the most fundamental concepts in all of electronics, Ohm's law. If you've ever been curious about how electricity works, this is the place to start. It's the key that unlocks the secrets of circuits. And trust me, it's way less complicated than it sounds. So, what is Ohm's law? Simply put, it's a formula that describes the relationship between three key things: voltage, current, and resistance. Imagine electricity flowing through a wire like water flowing through a hose. First, let's talk about voltage. You can think of voltage as the water pressure. The higher the pressure, the more forcefully the water pushes through the hose. In electricity, voltage is the push or force that makes electric charges move. We measure it in volts, symbolized by a capital V. A 9-volt battery has more push than a 1.5-volt battery. Simple, right? Next up is current. If voltage is the pressure, then current is the actual flow rate of the water. It's how much water is moving past a certain point every second. In our electrical world, current is the flow of electric charge. We measure it in amperes, or amps for short, symbolized by a capital A. More amps mean more electricity is flowing. Finally, we have resistance. Imagine pinching the water hose. You're creating a bottleneck, making it harder for the water to flow. That's resistance. In an electrical circuit, resistance is anything that opposes the flow of current. Every component, even the wire itself, has some resistance. We measure it in ohms, and the symbol for that is the Greek letter omega. A high resistance is like a very narrow pipe, while low resistance is like a wide open one. Now, let's bring it all together with Ohm's law. The German physicist Georg Ohm discovered a beautifully simple relationship between these three quantities. The formula is V equals I times R. That's voltage equals current times resistance. Let's see it in action. Suppose you have a simple circuit with a 12-volt battery and a light bulb that has a resistance of 3 ohms. How much current will flow through that light bulb? We can rearrange the formula to find out. If V equals I times R, then I equals V per R. So, we take our 12 volts and divide it by 3 ohms. That gives us 4 amps of current. That's how much electricity is flowing to light up our bulb. This formula is like a magic triangle. If you know any two of the values, you can always find the third. Want to find the voltage? Cover up the V, and you're left with I times R. Need to find the resistance. Cover up the R, and you have V divided by I. It's incredibly powerful. Why does this matter? Well, for anyone designing or fixing electronics, Ohm's law is everything. It helps engineers choose the right components to make sure a circuit works safely and correctly. If you use a resistor with the wrong value, you might get too much current, which could burn out a delicate component like an LED. Or you might get too little current and your device won't even turn on. For example, let's say you have a tiny LED that needs a 3-volt supply, but you only have a 9-volt battery. If you connect it directly, pop, the LED is gone. It can't handle that much voltage. But using Ohm's law, you can calculate the exact resistor you need to add to the circuit to limit the current and drop the voltage, protecting your LED and making it light up perfectly. From your smartphone to the power lines overhead, the principles of Ohm's law are at work everywhere. It's the bedrock of electrical engineering. Understanding it gives you the power to analyze, build, and troubleshoot circuits. It's the first big step from just using technology to actually understanding it. So, to recap, voltage is the push, current is the flow, and resistance is the opposition. And the relationship that ties them all together is the elegant formula V equals I times R. I hope this demystified Ohm's law for you. It's a concept that opens up a whole new world. If you found this helpful, give this video a thumbs up and hit that subscribe button. We've got plenty more electrifying topics coming your way. Let me know in the comments if you have any questions or what you'd like to learn about next. Thanks for watching, and I'll see you in the next one.